This is going to be a set of notes on nuclear fusion and fission. And by the end of the set of notes, we should be able to create a diagram that shows us the similarities and differences in nuclear fusion and fission. I'm going to start off today's notes by reviewing and going over nuclear reactions and chemical reactions. Nuclear reactions are changes in the nucleus. So whenever I talk about fission, whenever I talk about fusion, whenever we talk about radioactive decay, so everything we've gone over the last couple weeks, these are nuclear reactions because we're changing the nucleus. Nuclear reactions release a huge amount of energy. So think of something like the atomic bomb. That is a nuclear reaction. Compared to a chemical reaction, which releases or absorbs sometimes much smaller amounts of energy. So a fire would be a large amount of energy for a chemical reaction. Nuclear reactions release radiation, whereas chemical reactions don't. And in nuclear reactions, our elements are changing. So we could think of an example here. If we start off with polonium-208 and it goes through alpha decay, that polonium becomes lead-204, so a completely different element. Whereas in a chemical reaction, if we wanted to make water from hydrogen and oxygen, that water is still hydrogen and oxygen, just chemically bonded together. So those elements are not changing in a chemical reaction. I'm going to start with nuclear fission. Fission is when we split an atom. And I remember that word fission because it sounds similar to the word fissure, which is like a split in the Earth's crust caused from an earthquake. So fissure is a split. So usually we have really heavy atoms or really large atoms that want to go through fission. So an example is in our nuclear power plants, we use uranium usually to go through nuclear fission. And if we shoot it with a neutron, it becomes extremely unstable and it will split into two separate elements and release even more neutrons. And then you can imagine those neutrons that get released can hit more uranium atoms and cause them to split as well. We call this a chain reaction, and we can control it to generate certain amounts of power in nuclear power plants because we want to generate a constant amount of energy. If a chain reaction gets out of control, then you might have a nuclear meltdown, it might overheat, or you might have something like a nuclear bomb where you have a huge amount of uranium atoms all splitting at the same time. The next thing is nuclear fusion. Fusion is exactly the opposite. Fusion is when we combine atoms together, combine the nucleus specifically together. So I remember fusion because fusion foods are like a combination of two different cultures of foods. So an example is Thai curry pizza. It's like a fusion of pizza and Thai food. You got the kimchi burrito, which is like a fusion of Korean food and Mexican food. So fusion is like a combination of things. Fusion generates a huge amount of energy. Fusion is what happens in the stars. Our sun in particular takes hydrogen atoms mostly, fuses them together to make helium atoms. And that generates a huge amount of energy, and that's what powers the sun. So the difference between fusion and fission is fusion is combining, where fission is splitting. Fusion has little to no radiation because you're combining them, and there's no necessarily radioactive material that's being produced. Whereas fission, you're producing these other unstable atoms. Fusion is generating a huge amount more energy than fission. You could think fission, the first atomic bomb was based off of uranium and plutonium fission, whereas the hydrogen bomb is based off of fusion, and it's a huge amount larger. So why do we not use fusion in power plants? So the answer to that is in order for us to do fusion, we currently need to have a very high temperature in order to fuse our atoms together. So that takes a large amount of energy. So it's not worth it for us. We can't generate energy from fusion right now. So that's kind of like a science fiction dream that one day we can get all this clean energy from nuclear fusion and we won't have any radiation from it. So all our current power plants use nuclear fission to generate power, and a byproduct of that would be nuclear or radioactive waste.